Hi everyone, I'll be giving LeetCode weekly contest right now. I have to register and then give it. Damn, YouTube has done some things. It has updated a few things. Share my screen. Let me try to solve these problems. Find the degree of each vertex. You are given a 2D array matrix of size representing the adjacency matrix. So what is an adjacency matrix? Like you will know what all is attached to that. And what is degree? Just sum of ones, I guess. So sum of ones is the degree now. That's it. It's number of edges connected to it, right? So what we have to return? We have to return sum of degrees. Let's say, okay. For auto f matrix, okay. Int ret equals to 0 or deg equals to 0, degree equals to 0. For int value, let's say f degree plus equals to v, because if it is 1, I'm just checking that if there can be multiple edges or not. There cannot be multiple edges, so it's just sum. And then let's push this to degrees. Run and submit. Okay. I haven't slept at all. I haven't slept yet. I haven't slept. Even yesterday, I haven't slept. Baby doll, I can't move on. I can't move on, baby doll. Is it running? Bye, bro. Mm-mm-mm. What happened? I can. That's what I wrote before, right? But then what happened? Given a positive integer array sides of length 3, determine if there exists a triangle with positive area whose three sides are given by that. Isn't this a well known problem? What? We have to return this, it seems. We know sign rule, but isn't this complicated like them asking it right here? A by sin A equals to B by sin B equals to C by sin C. Mm-hmm. I think we know cosine rule. How can I prove that? Because my videos are my in my videos I involve proofs, right? I can recall a cosine angle, like cosine proof. It's like it involves root of s into s minus a, that one. I can recall that, but I'll try to prove it, okay? Want to get cosine. So how you write that is c equals to h equals to We can say h square, we can say b square minus h square root of plus root of c square minus h square equals to a, right? If we can get h from this, we can do cos inverse, I guess. Likely we can do cos inverse or tan inverse, because if you get h is nothing but cos inverse of that, right? H is nothing but what? A cos b or a sin b, right? Because h equals to b sin c. See, sine rule comes from just this: b sin c equals to c sin a, c sin b. And if you get that here, sin a by sin b equals to sin b by sin c equals to that. And how do you find this h square? You move one that side and then you square. Then what will happen? It will be c square minus h square. And if you know our prime minister telling a square a plus b whole square, क्या होगा अमेरिका और इंडिया मिले तो और 2ab निकलेगा. He told something like that, right? So let's try to do that. Plus b square minus h square, and ये होता है 2ab. 2a times root of c square b square minus h square. Okay, you can see that you can cancel out h square. See, how am I able to prove? I have studied this when during JEE, I guess, but I don't need any of your c square minus of a square plus b square by 2a whole square h square equals to b square minus, right? Baby, I can move. Wait. Why is it by 2a? Yeah, it is by 2a because I moved these things that side. Let me put it clearly. By 2a whole square equals to b square minus h square. H square, b square minus, yeah, we have h square. So we get h and then we get sine. And then we are done. But how do you handle obtuse angle? That's being weird, right? Because when it is obtuse angle, sometimes it is this. Sometimes it is this plus this not equals to a. This minus this equals to a. I don't know how things change then. But we can find obtuse or acute based on c square minus a square minus b square, right? With this value itself. Let's just keep plus or minus here and see what happens, okay? Then what happens is you get plus or minus here when you move that side, and when you square it, you get plus or minus here. You get plus or minus here, okay? So you get plus or minus here. And if you're having plus or minus here, it doesn't matter. So this is the answer, whatever it is. So we have h, and then we will get sine inverse of. I can Google sine inverse in CPP. This would work, it seems. Okay. So what do we do? This shit should be symmetrical, right? So let's just make it symmetrical, okay? 4b square s square, right? This is minus c square minus s square minus b square whole square by 4a square. Now, how do you simplify this? You do a minus b, okay? Then it will become 2ab minus of whatever the absolute value of it is. But it need not be absolute value because formulas work. Baby, so this is a plus b whole square minus c square times c square minus of a minus b whole square. So now we are coming to by 2a whole square. Now we are coming to the formula that I remembered, right? And now if you split this again, a plus b minus c times a plus b plus c minus a plus b times c plus a minus b by wait. This is 4, right? 4a square. Now let's apply root. H equals to root of. Let's try to apply s. Okay, let's try to multiply. This can be written as s minus c by 2. 2 times of s minus c, right? If uh, s equals to a plus b plus c, semi perimeter by 2. Okay, what is a plus b minus c? S minus c, 2 into s minus c, right? So you can write that as 2 into s minus c. S. What is this one? S minus a times what is this one? S minus b. B, b, uh, can move on. I can move on, baby doll. Ah, now I see it. If you see the circle, A will make an angle 2A at the center. And if you see that, if it is making an angle 2A at the center, A is literally okay. I will write some more knowledge for you guys, people. Okay, Excalibur. So if you guys, I'll drop some lore here. Okay, if you guys look at a circle and then you have a triangle. Okay, you know, oops, I'm drawing it with touchpad. Okay, my drawing skills are good because this angle, this side and this side are equal. If you extend this, then you can see this angle is equal. If that is x, this is x. If this is y, this is y. This is 2x, this is 2y. So if this is a, this total is 2a. And if this total is 2a, if you drop a perpendicular here, it will be a and a. Because the perpendicular splits it equally, this is a by 2. So what can you say? Sin a equals to a by 2r. So this is the formula that you remember, okay? Sin a equals to a by 2r. This formula you can remember. You might have remembered sometime. But I don't remember formulas, right? I'm like a big pro. So you get 2 here, 2 here, 2 here, 2 here. So you will get 16 by 4a square equals to, we have root, right? Equals to 4. Take that, it will get 2 times root of s into s minus c into s minus b into s minus c by a. This is h. I can move on. And what is sin a? Fuck, my charging is 2%. I can move on, baby, now. I'll go sit down. Like it is too hot, just like me. See, I've been doing so much of plane geometry purely out of my mind when I have no sleep. You guys shouldn't compare me with some other people who give you sheets, who give you topic names, who says I will take you forward, who says like see my sheet, lick my sheet, eat my shit, and they're not as entertaining as me do. They wouldn't be skipping sleep like I do, right? Is skipping sleep cool now? Okay, where are we? Uh, we have H. B sine A was bottom, right? Let's say this is B. B sine A is H, right? B sine C equals to H. This we had before. Okay? So if you substitute H here, 2 root of S minus A, S minus B, S minus C by A. If you keep that here, by AB. If you try to compare these two things, okay, what is sin A by A or sin C by C? Equals to 1 by 2R. So you can compute R and then you can use this formula, okay? So what is R? ABC by 4 of root of S into S minus A into S minus B into S minus C. But you know, you can actually prove that S into S minus A into S minus B into S minus C is area of the triangle. How can you prove that shit? Half AB, half into A, base into height is area, right? Delta equals to. Okay, we have another proof now. Delta equals to half AH. Okay, and we know delta, which is area, equals to root of S into S minus A into S minus B into S minus C. We can see that proof with this one, if you guys notice. See, with this proof you can see that, because if you send this A that side and if you send this half that side, this is delta, right? Rearrange that. A times H by 2 equals to root of S minus C, S minus B, S minus C. This is area. This is the proof that area equals to root of S into S minus A into S minus B into S minus C. Got it? So if you use this formula that this is delta, you can immediately get H, and then you can immediately get, let's just find A itself, ABC by 4 delta. So let's find delta, okay? Let's find R, and then let's find sine A, and then let's find sine inverse, okay? And delta equals to, and S equals to, should be double. Delta equals to, radius of the circle equals to, circumcircle equals to, ABC by 4 delta. Can move on. And then what do we need? Sine inverse of A by 2R is what we need, okay? Let's put that thing here, okay? For side in sides, answer dot pushback of assign of ABC by 4 delta, right? ABC by 4R. Okay, A by 2R. Side by diameter. You can prove this in a better way. Side by diameter. Instead of that, look at the place where it makes a 90 degree. What the fuck am I doing? No, no. Make it like this. So this becomes a 90 degree. You can see these two angles are same. That's a theorem. And if those two angles are same, if this is a diameter, this will be 2r. Baby, I can. So a by 2r is sine a. So this is good theorem. Do you guys see that? We have a theorem that I just proved that this angle will be constant, because if this angle is twice of this thing, wherever you take, if this is half of that, and that all these angles are same, if all those angles are same, make this 90, and if you make that 90, this will be 2r, and if that is 2r, and if this is a by 2r equals to sine a, because this is a and this is also a. That's circle's property. Learn some plane geometry. Okay, learn some plane geometry for the beauty of it. Okay, I learned it when I was in 11th or 12th. It's not there for JEE, right? Why did I learn? I learned in a way where I can recall right now. And then you guys will go. I don't waste any of my energy on unnecessary things. I will only see what's important by some sheet or if someone guides me. Just explore, not just try to enjoy problems, just try to do something. Don't be so cunning like the Indian mentality you guys have, like so cunning kind of thing. I will only do some shit. I will only. I'm sleepy. That's why I'm closing my eyes. Okay, I can open my eyes wide awake sometimes. Don't have that cunning mindset. Like, okay, I will only do the best shit. I will only do this one, and then I will get ahead of others. You get ahead of others by doing something, because you won't go far by doing whatever the fuck you are like doing. Mm, 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 mm. What the fuck is the problem? I forgot.
We were sitting this here 8 hours back, sitting here 8 hours back.
I'm not sleeping and I'm streaming, bro. I'm streaming some lead code problem.
Which question?
Some lead code. I need not do lead code.
You do lead code also.
I don't do lead code because I haven't slept and I realized that there is a contest I'm doing today. Sunday night contest. Sunday morning contest.
What I
I,
mean to ask is, you don't do lead code, right?
yeah, I don't do lead code because it's like too easy for me.
Yeah, baby. I do confidence. So how long have you been doing this competitive programming?
Mm-mm. It's been quite a while right now, bro. 180 by pi I have to do.
Hmm?
It's been quite a while. I started in college. I have no reason to do right now also, but I'm somehow doing.
No, money should do it, right? It helps you in interviews and everything.
Yeah, I'm just doing it for fun and for my YouTube channel.
But now does all the questions come easy to you?
Yeah, quite.
Like hard questions lead code. Because I'm not in competitive programming, but I do just lead code.
Yeah.
So does questions come second nature to you, or like how is it?
There's questions?
Come as second nature to you, can visualize things like that.
Yeah. Most of the easy questions. I'm still giving code forces too. There is 11 o'clock code forces contest that I want to give. Uh,
Competitive coding is mostly maths, right?
yeah.
Maths and advanced data structures, maybe.
Yeah. Actually, the area will be less than or equals to 0. So you can put the check here itself. If this is less than or equals to 0, return is return. There was some geometry related question. I was just doing it slowly.
Yeah, like these are mathematical questions, right?
There is one little bit of geometry related one where they should not, where they need not have done this, but they have given this somehow. Let me just turn on. It's not int, it's double.
Oh, word. Hi, Yush. यार आप निकल रहे हो क्या अभी?
What's the problem with this
क्या क्या?
sorting?
अच्छा होपफुल लग तो रही है.
Ow. Ooh, ooh.
नहीं मैं 9 बजे तक पहुंच जाऊंगा. नहीं हार्डली हार्डली आप ये 5 मिनट तो वो मान लेना. इससे ज्यादा लेट नहीं है. ठीक है. श्योर ठीक ठीक.
I can't be using sign because sometimes it will be wrong. So I will always give an acute angle, right? But I have to do something else. If s minus side less than or equal less than 0, because it cannot be equals to, because then it violates. Then semi-perimeter is less than side is greater than semi-perimeter, which means that is obtuse side. For that you have to do
Teja, it's still on. You still switch on the filter.
really.
It's still flooding. How do you forget to close?
It's not me, bro. I didn't drink water.
It's anyways, people are forgetting to close. How is possible?
Yeah, bro. You have to keep a CC camera over there, bro, and
What CCTV
capture the culprit.
like,
Because people are just putting blame on me, bro, and I don't think I'm doing that. I'm the
what?
only one awake. No one is there. So like should be me, like because no one came here.
Let's see, nobody was awake.
But I don't believe it's me. So
Really go to the kitchen.
if it is this, then let's just do this.
Can be the case, man. Can be the case.
Yeah, bro, it can be some ghost too. That's why we need CCTV. This might do it.
हेलो. हाँ ब्रो हो गई बात. मैं ये कर रहा हूँ कि मैं 9 बजे 13 यहाँ आता हूँ. ठीक है. तो मैं गाड़ी से आ रहा हूँ. फिर आयुष कह रहे हैं कि साथ ही चल लेते हैं. मैं मेरे को सिर्फ ये है कि भाई अगर लड़कियों ने लहंगा वगैरह पहन रखा होगा भाई तो बहुत दिक्कत हो जाएगी गाड़ी में. ऐसे 5 लोग हैं ना हम लोग. अगर उन्होंने लहंगा पहन रखा होगा तो थोड़ा सिटिंग की इशू हो जाएगी. बाकी तो दिक्कत नहीं है. साथ ही चलने के लिए कह रहा था आयुष. मैंने कहा कोई दिक्कत नहीं है. बस ये ना हो कि फिर दिक्कत हो जाएगी. लाइक मतलब जगह नहीं हो रही फिर. चल तू रेडी हो गया क्या? हाँ भाई मैं कोई कपड़े अपने प्रेस नहीं कर रखे भाई. अभी कपड़े प्रेस करूँ मैं. चल ठीक है. मैं रेडियो को निकलता हूँ. ठीक है.
What? I just fixed this, right?
चलो. तेरे पार्किंग है? है ना, क्योंकि मैं गाड़ी से आ रहा हूँ, तेरा फिर मैं पार्क कर दूंगा तो साइड में दिक्कत तो नहीं होगी फिर।
So here
चलेगा भाई, चलेगा, ठीक।
S is 1 plus 1 plus 3 by 2, which is, oh, so this is not the, for obtuse angle, this is not the condition. For obtuse angle, the condition is a square plus b square minus c square, right? Which is nothing but, if this shit is less than 0, minus 2 times. That means a square plus b square minus c square less than 0. Then you have to flip it. This will be right. Now we are at one more medium. You're given a binary string is consisting of characters 0 and 1s. The string is balanced if it contains an equal number of zeros and 1s. You can perform at most one swap between any two characters in S and you select a balanced substring of from S. Return an integer represent the maximum length of the balanced substring you can select. So they want that you can at most after at most one swap they want maximum length maximum length that has maximum length substring that has equal number of ones and zeros, right? So how do you solve this? Is we should try to see optimal because there is an optimal substring, right? So let's look at that optimal substring. Somehow that's the answer. Let's try to look at that one. If you do a swap inside this substring, it's useless, right? Because number of zeros and ones doesn't change with the swap. If you do inside the substring, and outside the substring, if it's purely outside, even that doesn't help. So you have to do inside and outside. So for that outside you may be using 0 or 1. So all you want from the outside is there a 0 or is there a 1? Okay, and all you want from the inside is again if there is a 0 or there is a 1. So here the count should be some x and x minus 2, so that when you swap this with this it will become x plus 1 and x minus 1, sorry. So when you swap it will become x minus 1 and x minus 1. So this should be the substrings count. Okay, so you can actually brute force things. You can brute force that one is the one that is getting swapped into inside, and you can say that one is coming from right side or left side. Okay, now as you keep going this direction, as you keep going this direction, as you keep going in this direction, you have to find sum such that the sum equals to sum of zeros minus sum of ones equals to 2 or minus 2. And based on that you will see if there is a 1 on this side or not, because you want to cover all the things, right? And in that way you can know what's the maximum substring that you can get here this side. And if there is one or not, based on that it will be useful. If there is no one on this side then it's gone already. If there is one, then you have to find the maximum substring with sum equals to plus 2, and then you can swap and it's possible. So you have to a bit formalize these things and then find these things. You can maintain a map with the prefix sums, and if you have prefix sums, then you can get the, for any prefix you can get the what's the index that is there. So with that you can get the for plus 2. All you have to need is there a plus 1 this side or not, is that's what you need. Okay, is there a plus 1 this side or not? Okay, is there a 0 this side or not? That's all you want. Okay, how do I get that? I'll just maintain count 0, count 1. Okay, with that I'll iterate from this side to this side, and then with that I'll try to get this one. But char cs c0 plus equals to c equals to 0, c1 plus equals to c equals to 1. Okay, now let's iterate through the characters. Let's make prefix sums. Okay, in prefix sum, let's just define n equals to size of s dot size of, and vector int. I'll put all the formulas that I wrote on question 2 on my thumbnail for this thing. I'll make a thumbnail quickly after this thing is done. I'm only one team being able to provide beautiful solutions. You guys cannot appreciate enough. You guys cannot appreciate, maybe because you guys cannot understand what am I doing. I need not even maintain this. I can just have some, and then I have a map. First occurrence, let's say. Uh, gives first occurrence where ref sum equals to val. So we have 0 at 0 index, right? We want to know index value. Mm, I'm taking one best. So what am I trying to do? I'm trying to find out for all prefixes. I'm trying to store their first index, because this is a quite common problem, right? I want pref of I minus pref of j, where j less than I equals to plus 2 I want, let's say, or equals to plus or minus 2 I want, right? Which is nothing but pref of j equals to pref of I plus or minus 2. And I want to maximize I minus j, means minimize j. So you want to find the minimum j like this. Okay, how do you find the minimum j like that? Once you get sum, you have to do minimum of, not minimum, if it is not there, only then you have to do if first occurrence dot count of sum equals to 0, only then like you will set it I plus 1. Okay, we are using one based index. Sum plus equals to, let's say sum equals to c1 minus c0. Okay, so far how many ones have occurred? Minus c1, right? When it is 1 we do plus 1. Okay, and now what? See, I want to do it on both sides because I assume in first assumption I assume 0 or 1 is on right side. In the next assumption I assume 0 or 1 is on the left side. Okay? So what will I do for that is, what was I made for? I'll make a fun and then I'll put this logic inside and then I'll reverse S and then I'll just get that one. Okay? I put the whole logic. I should put the whole logic itself inside this one because I have to reverse S once and then give the answer back. And what should we do here inside now? So we have an answer, possible answer. Okay. If so, if it has already occurred before, okay, then you can have answer equals to max of answer comma I plus 1 minus first occurrence of what I'm doing here is finding zero subarray without any swap, right? So this is one possible answer. Now using one on right. If you're using one on right, what is the current sum of this one? Because you want to have two zeros here. Means it should be minus 2 because then 0 will go, it will become minus 1 and the 1 will come, it will become 0. Now we want proof minus 2 if first occurrence dot count of, you want the sum to be minus 2. So you want this to be minus 2 and if you want that to be minus 2, pref of j should be pref of I plus 2. It should be sum plus 2. Okay, answer equals to max of answer comma I plus 1 minus first occurrence of sum plus 2. Now using 0 on right, for this c1 should be greater than 0. Using c0 greater than 0 and first occurrence dot count of sum minus 2, answer equals to max of answer comma I plus 1 minus first occurrence of sum minus 2. See, I'm being very clear. I'm trying to use the right side one. And next time I will reverse the string so that left side one will also be covered, okay? Code can always be written beautifully if you don't stress. You have to be calm, you have to be chill. Have you slept yesterday or not? You have to be chill. You have to operate chill. Have you eaten anything? Have you had food or not? You have to be chill. No panic. Whatever happens, you have to be chill. You have to be calm. And then you have to solve the problem. Okay? I thought I saw your face today, but I just turned my head away. This should ideally work. See, it got accepted. Brute force is what I have done. Simple code. I'm only doing one iteration. I just found the total number of ones, total number of zeros, and then I'm removing zeros and ones so that I have the count of the remaining things. I thought I saw your face today, but I just turned my head away. Good subsequence queries. See, my standings doesn't matter because my solutions are beautiful, right? When you see my solutions are beautiful, right? Just like me. I'm wearing dark circles because I'm not sleeping at all these days. I don't wanna get dark circles. I wanna look good. Who doesn't wanna look good? I thought I saw your face today, but I just turned my head away. I was thinking about the thumbnail, okay? Not this problem. Let me read the problem. You're given an integer array nums of length and an integer p. A non-empty subsequence of nums is called good if the length is strictly less than n. The greatest common divisor of its elements is exactly p. So it should be a subsequence, it should be non-empty, it should not be full, it should be less, like it should not take whole, and its GCD should be p, okay? So look at all the numbers that are in the subsequence. All of them are divisible by p. That's one constraint you have. You're also given a 2D integer array queries of length qa, queries of where each queries of I equals to int of I, comma val of I, indicates that you should update nums to val. So you have queries. After each query, determine whether there exists any good subsequence in the current array or not. Return the number of queries. So it seems not that difficult, right? For which a good subsequence exists. So you have to keep doing updates. First solve the problem for one. Array is changing, okay? But we are no panic. We no panic. We are not panicking. First solve for static array. Okay. P is fixed. And what's the value of P? Not that big. You want GCD. You want to determine if it exists or not, okay? So GCD of total minus 1. Okay, GC of D of something equals to P. Okay? So let's just say, uh, look at things that are divisible by P. Okay? If there exists, let's try to say what we can say if there exists. That GCD should be equals to P. So if divisible less than n, then S if S implies and implies GCD of this equals to P. Done. I'm using necessary condition and I'm trying to use sufficient here to simplify the code. Else, if all are divisible by P, we have to be a bit more careful in this case. Okay? Can you remove one thing and have GCD equals to P? Is the problem here. Or you can write it better. If GCD of not equals to P, return. So now all are divisible. So this is S. So now all are divisible. Can you remove one and still make the GCD equals to P? This you have to answer. This you have to answer. You can do this in number of primes in P because all are divisible, right? And then you try to see how can you do this one? How can you remove something and then check quickly if all of them are divisible? If there is a GCD, if GCD still is 0 or not? I know how can you do that. I know how can you do that. Let's use logic. Okay, never use memory. Don't bring your stupid memory. Let's try to see what if this doesn't happen. What if this doesn't happen? Means, see, removing one is optimal, right? Means whatever you remove, their GCD is greater than P. Okay? Total GCD is P, but even if you remove anything, GCD is greater than P, and you have to test this one. If GCD is greater than P, then the divide P times some prime P1, where P1 is some prime of P, right? Because fuck, it need not be some prime of P1. Okay, P1 is some number times Q, where Q is some number. Greater than 1. So if this happens, then there exists a Q greater than 1 such that it divides all of them. There are n minus 1 multiples of P comma Q, P times Q. See, now this is necessary and sufficient. It's all about necessary and sufficient. All the problems are about necessary and sufficient. I made a video explaining necessary and sufficient as an animated video, but then I haven't yet posted that on my channel. So guys, check out when I post that finally, okay? Because I do too many things. I do so many things that I don't get time to do anything. I'm not even sleeping because of so many things that I'm doing. You know, if you think, I'm thinking how to do that, how to find this Q is what I was thinking. Q greater than 1. This cannot be max value. So all you want is max frequency of multiples of P times Q. If this is less than n minus 1, you are done. Because There is no such queue. If there is no such queue, how can this be possible? This is a necessary condition, right? There are n minus ones. If this fails, then you are done, because then you can definitely remove something, and this is possible. But if this is not possible, that means there is some p into q that's there in n minus one things, right? And it's not there in only one thing. You remove any other thing. What? No, no, I'm not doing it right. It can still be possible, right? This is not tight. Logically, it's being necessary, but this is not being sufficient. You have to brute force over all of them. See, one thing you can brute force all of them, but that's not possible, right? Maybe can you say something about number of such queues? Yeah, guys, where am I? Max frequency multiples of this is n minus 1, right? So let me think, because this is like, this q is there in n minus 1 things. That's a necessary condition. But if that happens, you cannot disprove that. You cannot say it's not possible. You cannot say that it's not possible. If it is if it is possible, then this will happen. But you still don't know that, because it's there in all of them, but not there in one thing. Okay? Let's look at all such queues logically. Okay, let's look at all such queues that are n minus 1, n minus 1, n minus 1. We want to determine, is there a way to remove something, and then there is no such queue. Is there a way where you remove something and then, okay, what does this mean? Is there a way to remove something, then all of them are disappearing? Because even if, no, no. Is there a way to remove something and all of them disappears? Because is there a way to remove something and no queue should be present here? Which means, implies. So the problem now is there a way to remove something? And see, if it is yes, if you cannot, if there is no good subsequence, then there is a potential queue. Let's look at those potential cues. See, I'm using pure logic. Everywhere I'm using pure logic. No topics at all. This is necessary and sufficient conditions, like applying logic. You guys should get better at this. But you guys don't do that. You guys think it's knowledge. Like, I don't know this Indian mindset. Like, I like Indians, but I'm an Indian too, but that's very typical of us somehow. It's very typical of us. Like, I mean, if you see industries, I don't think these industries are present in even tourist country, right? The industries of sheets, like we do the sheets, we grind, we get a job, SDE job, and then I had success. Let me solve the problem right now. Just live your life. The problem now is there a way to remove something? And then there is no queue. Did I get a hint match? Nah, it's screen time, it seems. Da-na, 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 da. Kilare tere ek jaan. So there is no queue that divides all of the n minus 1. Means for all the potential q, the place where they were missing should be same, else there is no such a thing, right? And if the place is actually differing, then you cannot remove something and expect everything will be there, because you can remove this thing, but then there are values that are there on more than n minus 1 things, okay? And there is a value that is outside of this, and it is having covering everything because it's there n minus 1 times. And if it is there here, let's say, not all such things can fall here. So there is some value that is there completely outside because fuck, it's becoming a bit complicated. It feels like there should be n queues, but because for each of that thing you choose, okay, yeah, it seems weird. If there is only one thing, which is nothing but the queues should divide all the other things, only then it's not possible. So this means logically the case is you remove something and then there is no queue that divides all of this. And then if you're looking at these potential things, what does that mean? Oh, all of them has one of that here. So what does that mean? Okay, after you remove that, all of them are missing something, right? That should not be this. Not same. Yeah, now it makes sense. So there is a place where nothing is missing. Okay, they cannot appear n times. All of them are appearing n minus 1 times. Nothing is missing, which is same as there is a. Okay, how many potential queues can you have? They're dividing n minus 1 things. They're dividing almost everything. They're dividing almost everything, right? I think there cannot be many because can you always find those potential queues and mark where they are missing, mark where they are missing, mark where they are missing? For that, you should be able to iterate over all its divisors. It's 128, so it should be possible. For all the divisors, I will maintain these counts, okay? And when they reach n minus 1, I will maintain. For all devices, I will maintain its counts when it reaches n minus 1. Yeah, bro. Actually, for all the devices, you can add that value here also because Number of devices is at most 128, right? In one thing. So if everything, so for all the devices also it will be at max 128. The total sum will be that, because for each device you're adding that index, right? Which is nothing but counting those devices in this thing, which is less than or equals to n times 128. So even that will be less than or equals to n times 128. Is there a simpler solution? Is what I'm trying to see for some time. Yeah, LeetCode one itself. Mhm. For things that reach n minus 1, you have to find the one place they are not there. Okay? Can I code this in 10 minutes? It's quite complicated. We only need some. We also need count. We only need count and sum of the divisors for each of them. We need not even store the indices, because I'm going to use sum. I'm liking this. I'm liking this because I'm not using any data structures. That's why I'm liking this. See, what I'm doing is, for each divisor, for each queue, maintain number of things that divide, number of indices that divide uh, p times q. Also find this sum of these indices. Okay, This is not difficult right now. So what I have to do, I have to just find divisors, right? Okay, I'll try to find divisors first, all for all of the numbers. Okay, bounded by 128. Each of them is bounded by ra ra Rasputin. How do you find the GCD though? It's not easy. You should just console is not enough. You should be able to say if there is a q that is there greater than or equals to number of divisors. You get number of divisors count easily, but then you have to see if there is some other q with the same number that you have to maintain before itself. So you want max and its count. You want max and its count, number of maxes among these queues. This shit is quite complicated. Frequency of max count. I'm maintaining so many things. But all are basic. But how can you remove something and then update the max count? It's not that easy. That's not possible. I'm not able to find the GCD. Well, okay, find the indices itself and then just store indices also. Then you can do it. I just proved that indices will not differ much, right? Just go over all those indices for P and then just check the GCD. That's the simplest way. That's the simplest way. And then what should I do? If x reminded p, continue. Or if x not equals, if x reminded p equals to 0, then what should we do? You have to, this should be a set. And actually, if you have the set, so now we have this queue, right? All of this divide this thing. And if all of them divide that thing, we have to increase their count, we have to insert this thing, okay? I'm inserting I because that divides that. And then also sum of q I will add plus equals to I. And count of q I'll add plus equals to 1. Okay? Now what you should do with queries? We'll get idx equals to f dot 0, I guess, f of 0. Because the format is ind comma val. Okay? Now we have to find its current value in the array. 0 based index, I've just checked that. And then you have to update these things. These are very clear. But you have to erase now for all the devices. You have to remove this from some, you have to decrease the count. And then what you should do? You should update nums of idx to val. And then you have to do the same thing again. And then you have to insert this again. So in this way, you're able to maintain all of them. You have updated and then you maintained all of them for all of the P's and Q's, right? Now, see the count of Q, okay? So let's just try to find the GCD of Q itself. Wait. You cannot go and find the GCD by one. Maybe something like square root decomposition helps better than whatever the fuck I'm doing. Maybe their asymptotic sum is less than or equals to 128 times n, not individual. You cannot just go over individual to check the GCD. Okay, here are some things that divide p. How do you check the GCD of them quickly? This number won't be too small. Ra ra Rasputin. I only have the problem with finding GCD. I thought if I just store maximum, I can do this, but then but getting maximum is enough. Maintain mul p equals to 0. Okay, and if it is a multiple of p, we'll do mul p plus plus. Yeah, but the problem was I cannot find maximum after changing a value. But you can find maximum if you keep those shitty things in a set again. I need not find this if I also insert 1. Okay, let me also insert 1. Then 1 will be our basic. Okay, idx of 1 will be all the things that divide p, right? I have some work to do. So what we have to do is we have to find maximum of count of this if x greater than 1. I think I need not skip x. We added once, we'll erase it once. Now what's the condition for GCD? Whatever the max is, max value, this will be number of things that are divisible by 1. This will always be count of 1 because that will be maximum. Number of things divisible by p, okay? And find this count in the set S. There should not be more than 1. I think this should be done for Q. This value is getting updated, right? So what are we having in the set? We have for each of the Q, we have these values that are possible, right? We are having those counts in the set. Each time it's getting updated, you have to erase the previous count and then add the count. Otherwise, it will be wrong. So remove the old value, added the new value for this Q. And this we should do every time. Now we have to check. Okay, first we'll check GCD. Because count of 1 will always be there, right? Which will be the maximum. And now we have to think. Now GCD equals to P. If max frequency equals to 1, sorry, see less than n, then you have your answer. Continue. Now max frequency equals to n minus 1. So this is troublesome. Sorry? Now what you have to do is there is something that is not failed by some queue. So my idea is correct. Whatever the indices that are failing, when some count becomes n minus 1, okay, when some count of q becomes n minus 1, you want the value, you want to store the value in the set for that index. You will mark it as failed. మా ఇంకో 5 నిమిషాల్లో కాల్ చేస్తామా ఇప్పుడే? We're not using IDX anywhere. Remove that. Our logic is we want to find where it is not used, okay? For this queue. And when its count becomes n minus 1. When will its count becomes n minus 1? After adding something, right? I hope n equals to 1 is handled. Yeah, n is not 1. So its count became n minus 1. I'll use one based index. Its count became n minus 1 means there are n minus 1 things that are dividing. So I want to know the failing one. What will be the failing one? N into n plus 1 by 2 minus sum of q. This will be the failing one. And you know this failing one, okay, this is the failing index. You want to keep track of how many times it's failing, and you want to have zero failed ones, okay? Now you are failing this once, okay? You want the count of zero ones. Initially nothing has failed, right? Thought you were too good for me, my dear. Never gave me time of day, my dear. And once this happens, before this, if fail idx of failing idx equals to 0, count fail will increase, okay? Let's just exclude q equals to 1 from this case, because that's the only place where everything will be divisible by p. This we might have marked as fail, right? But now if it becomes 0, it is free again. So my solution says if there is something fail, something less than n, something that is not failing, you can remove that. And once you remove that, for every other queue, something will be missing. So you cannot have a queue that divides everything. What the fuck? Will this pass? My head is hurting. What happens here? This will become 7. There is a case where count of q can become n and then drop down. How am I handling that case? This is not that case. Why? Why is it really? Don't go TLE. This is shit. It's failing randomly. I'm ending. This is correct solution. I'm ending it. I'm ending the stream.